All right, here we have notes 6.4 on negative exponents. So this is the sheet that you're using, your note sheet, and I just zoomed in here on the rule for negative exponents. So if you have a negative exponent, what you're going to do is you're just going to move it to the denominator and make the exponent positive. So here we had x to the negative a, we moved it to the denominator and made it to the positive a. If it's not in a fraction already, what you're going to do is you're just going to put 1 in the numerator and then your term with the positive exponent in the denominator. Okay, and just like by the same type of rule, if you have 1 over x to the negative a, you can just move this to the numerator to make it positive. So it would be x to the a, which is technically x to the a over 1, right? So you can see how it's in the numerator, but we just don't write the 1. Okay, so you can go back and forth that way. So if it's in the numerator, you can move it to the denominator to make it positive. If it's in the denominator, you can move it to the numerator to make it positive. So let's take a look at some of these examples here. So number 1, you're asked to rewrite each expression using positive exponents. Okay. So we have here x to the negative 5th. This is technically over 1, right? So it's in the numerator. So we can write this as 1 over x to the positive 5th. Okay, and that is how you make it positive. So here, let's try this. We have 3 times m to the negative 2, which is over 1. So we can move this. We're going to leave 3 in the numerator, and then we're going to move m to the positive 2 in the denominator there, okay? Because 3 doesn't have an exponent, a negative exponent, it's just going to stay up top. Okay? Let's say that's equal to, and then this last one, okay, we have a positive exponent here and a positive exponent here and a negative exponent here. So we're going to leave the positive exponents, negative 7 and b cubed, in the numerator, and then we're going to move a down to the denominator and make its exponent positive like that. All right. So here we have some problems, some mixed problems, asking you to simplify each expression. So I'll just go through and pick out a couple and show you how they work with the other exponent rules, okay? So here for number 4, we have w to the 7th times w to the negative 9th. When we're multiplying two numbers with the same base, we're just going to add the exponents, right? So we have w to the negative 2 after we add them together, and that is equal to 1 over w to the positive 2. Okay, hopefully this is making sense to you. If not, just send me an email and I can do go in a little bit further. Okay, so it looks like these are all multiplying. Let's do a power of a power. So here, since we have this exponent on the outside, we're going to be multiplying these two together, and then we're going to be applying it to both those terms. So we're going to have 8 to the negative 2 p to the negative 10. Okay, and then since these are both negative, we're going to pop them into the denominator here, 8 squared p to the positive 10. We're going to put 1 in the numerator, and then we're going to simplify this guy here because we do know what 8 squared is equal to. So this is 1 over 64 times p to the 10th. All right, so let's see, let's do a division one. 13 looks pretty good, a little tricky. All right, so we know when we have a division, we're going to take the exponent from the denominator, so we have c and c, the exponent in the denominator, and subtract it from the numerator. So we're going to have c to the negative 2 minus 7, okay? And then we're going to do the same with this d term here. It's going to be multiplied by d to the negative 1 minus negative 2. Okay, so make sure you're keeping track of what's going on here. Make sure to keep the negative 1 stay negative, and then you're subtracting the bottom ones here. Okay, so c So we'll do negative 2 minus 7. That's going to give us c to the negative 9th. And then here we have negative 1 minus a negative 2. Well, we know that when you subtract a negative, that actually turns into a plus in addition. So we have negative 1 plus 2. That is equal to positive 1. So then we're going to have d to the positive 1, but we don't write it. If the exponent's 1, we don't write the exponent at all. So we have c to the negative 9th d. D has a positive exponent, so we're going to leave it in the numerator, and then we're going to put c in the denominator and make its exponent positive. So we have d over c to the 9th. And that is our final answer there. Okay, so it looks like these start to get a little bit more tricky. We've done one of each: multiplication, a power, a division. So let's do one of the mixed practices. And then if you have more questions, can always let me know. So let's do number 20. This has an addition in it. Okay, so we see these powers on the outside. So that's what we're going to do first. We're going to apply this negative 2 exponent to each of these in here. Okay, and remember, when we do that, if it already has an exponent, we're just going to be multiplying them together. So we have 4 to the negative 2, then x to the 3 times the negative 2, which is negative 6, and then y to the positive 6 times negative 2, which is negative 12. Okay, and then we're going to do the same thing here. Negative 3 goes to the 2, it goes to x squared, and it goes to y to the 4th. So we have 2 to the negative 3. We have x, and then we're multiplying the 2 times negative 3, which is negative 6. And then we have y to the 4th times negative 3, which is y to the negative 12th. Let's simplify this a little bit. We'll simplify these constants here so we can simplify these constants first. Yeah, we're going to move these to the bottom to start. So we have x to the 6th over y to the 12th. And we're actually going to make this 4 over 1 its own fraction. So we're going to put this 1 over 4 squared out front. And then plus 1 over 2 cubed out front. And then x to the negative 6, x to the negative 12th. We can simplify this even further. These two, this is 1 over 16, x to the 6, y to the 12th, plus 1 over 8, x to the negative 6, y to the negative 12th. I keep writing x. These are y's here. Sorry about that. Y and a y. Okay, so now we have like terms here. Right, we have our x to the negative 6, y to the negative 12. So we can just add these by adding our constants here. So first we'll have to make this 1/8 into a fraction with 16 as a denominator. Okay, so we'll have 1 over 16, and then x to the negative 6, y to the negative 12. And how we're going to do that is we're going to multiply the numerator and the denominator by 2. That will give us a fraction that is 2 over 16. And then the same variables here. And then we can just combine these coefficients to add them together. So 1/16 and 2/16 is 3/16. So this is equal to 3 over 16, and then we have x to the negative 6, y to the negative 12th. Okay, and then we'll just simplify because we always give our final answers with positive exponents. So since this is negative and these exponents are negative, we're going to move them to the denominator and make the exponents positive. So we're going to leave 3 up top. Then we're going to have 16, x to the 6th, y to the 12th. That is our final answer. And that was a little bit lengthy there, but that's pretty much as complicated as it's going to get. Okay, so that kind of had a little bit of everything in there. All right, so try these other ones on your own. Here's a challenge problem. I highly recommend you do this challenge problem to help you on the quiz and homework. If you want me to do a video on any of these problems that maybe you're struggling with, just send me an email with the number and I'll send you a video. I'll send everyone a video working out the problem.